then we are going to move on to lesson 2.2b, the second installment of these notes. And I can't remember how long I slated this for. Let me check my calendar. I think I was slating it for, yes, we're going to finish it today. We will move on to 2.3 tomorrow. A rational function is any function that can be written in this form. Legitimately, x is on top and bottom. Rational function. But if you write it in this format, c can't be 0. The reason why is because if c was 0, there wouldn't be an x on the bottom. So, you can't have a 0 in front of your x on the bottom. It doesn't make any sense. Axes, intercepts, this is what IB calls them. We're legitimately just saying the x-intercepts and the y-intercepts. IB likes to say axes, intercepts. So when do they happen? Well, if you're on the x-axis, the horizontal axis, then your y values are 0. You want to know where something crosses the x-axis, you plug in 0 for y and you solve for x, like we did with quadratics. Quadratic equals 0 means the y value there was 0. If you want to know where your y-intercept is, and there had better only be 1, because if there was 2, it wouldn't be a function, right? Better only be 1 y-intercept. Well, when you're on the y-axis, you're vertical, so x is 0 there. You would legitimately just plug in a 0 for x and see what y value you get. And that would give you your y-intercept. But one of the things you can't do with a rational function, like any fraction, is divide by 0. So the denominator, cx plus d, cannot equal 0 ever. You can't divide by 0. It's a no-no. And that is why we get vertical asymptotes on rational functions, because there is an x you're not allowed to use. Now, horizontal asymptotes for IB, because I do something slightly different for pre-calc, actually a lot different for pre-calc. Horizontal asymptotes are going to be what happens as x gets ridiculously big. And that means ridiculously big on either side. So heads towards positive infinity or heads towards negative infinity. It doesn't matter. Yeah?
Is there an actual finite number that could be described as when a line is essentially vertical? I mean, obviously,
No.
definition, no, but is there ever a point where you can cut off and say, yeah, this is the asymptote?
No.
Or when a graph would quit trying to graph?
No, the graphs go forever. They forever get infinitely close to the asymptotes and things like that. Because you can always cut any distance in half, right? It doesn't matter how small the number gets, it'll never be 0 technically. But anyway, so our horizontal asymptotes are going to be the y value you get as x gets really, really big in either direction. It's usually a over c. And if you look back to up here, a and c are right here. Oh, I circled those poorly. Let's try that again. Right there. Leading coefficient divided by leading coefficient. And I say usually because what if there's no x on top? Well, if there's no x on top, what does a equal?
1, 0.
0. So it always works as long as the exponent of the top is equal to the exponent of the bottom. In IB, we don't do all of the rational function stuff. IB generally sticks to linear over linear. So power of 1 on top, power of 1 on bottom. Yes, there are other things, but IB doesn't really do them at IBSL level. They might in HL, I'm not sure. But basically, as x gets really, really big, all that matters is the number in front of the x's. And you might be wondering why. Well, let me make up a quick example before we do this one. Let's just say I say y equals 3x plus 1 over, 5x minus 1. I can tell you this graph has a horizontal asymptote of y equals 3/5. But not just because I read the rule and I just used the rule. I understand why that's happening. So let's let x get really, really, really big. Let's let x get near infinity. Let's say x is like 10 quadrillion, okay? You plug in 10 quadrillion to the top x and the bottom x. The top one is 30 quadrillion and 1. Did the 1 really make that much of a difference? No. So basically, the plus 1 can be forgotten about. And then you plug a 10 quadrillion into the bottom, and now you have 50 quadrillion minus 1. Well, did the minus 1 really affect 50 quadrillion all that much? Not really. So essentially, as x gets bigger and bigger and bigger, this means less and less and less. And then you just simplify, the x's cancel, and you get 3/5. So that is why it's usually leading coefficient over leading coefficient. And I could have said the same thing for negative x. It doesn't matter. Negative 30 quadrillion plus 1. Woo. You know, it doesn't matter. Not much has changed. When x gets astronomical, constants start to mean near nothing. It's pretty neat, right? I mean, it's like if you were stupid rich and you saw $1 on the ground, you probably wouldn't pick it up. Yeah, like Bill Gates, like, yeah, he would, if he like bent down to pick up a 20, he would have actually lost money in that time or something like that. Yeah. 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 They used to say that there was a time when Michael Jordan was the same concept. So what we are going to do is all 5 of these parts, and I'm going to be using some symbols that might look new to you. First of all, it says determine the equations of the asymptotes. So part A. The easy one's the vertical asymptote. That one should jump right out at you. The VA, vertical asymptote. Someone want to give me the equation for that? What do you do? X equals 1. Because you set the bottom equal to 0. So yeah, so for this one you go, okay, the vertical asymptotes happen when the bottom equals 0. So yeah, x equals 1. The vertical asymptote is x equals 1. If you have a test question that says write down the equation of the vertical asymptote and you write 1, you just lost that mark. It must say x equals because they said equation. The horizontal asymptote, write down the horizontal asymptote. Well, both the top and the bottom are in standard form, meaning the x's came first. And since they are both linear, our constants of +1 and -1 mean basically nothing. That means our horizontal asymptote would be 2/1. Y equals 2. Do you remember yesterday when I was graphing and I made the mistake on the 1, and Kylie, you were like, oh no, it doesn't go. And I was like, oh, that's right, I should have been more careful. It's because I was ignoring the horizontal asymptote. I just didn't care about it at the time. And as soon as you said that, I was like, oh, that's right. And then I knew that number was a 1 or something like that, or a 1/3 or something. Yeah.
I understand that it's like a horizontal asymptote, but
Yeah.
why can y never equal 2?
No, it's not that y can't equal 2, because graphs actually cross their horizontal asymptotes often. It's not a thing that y can't be. It's a thing, and that's the problem. Students have this idea that asymptote is a line they can never touch. It's like, well, that's not always true. You can never touch a vertical asymptote, but you can touch a horizontal asymptote because there's no such thing as a horizontal asymptote. Instead, what it is what we call in pre-calculus an end behavior model. All you're doing is describing to me what the graph is going to be doing to the far left and the far right. Now, this one, the way it's written, it will never equal 2. And here's why. The top will always be double a number plus 1, and the bottom will always be whatever that number was, -1. So it'll get dangerously close to 2. For example, let's just plug in 1 million instead of 10 quadrillion. Let's plug in 1 million. The top is 2,000,001. The bottom is 1,999,999. And if you divide that, woo, you're going to be close to 2. But it won't be equal to 2. And the bigger x gets, the smaller the gap between those numbers becomes. But the gap always exists. Now, if you got rid of both of these, now the gap doesn't exist, and now it equals 2. You couldn't even get rid of just one of them. You do this, the gap will always exist, no matter what you do. You would have to get rid of both of the ones in order for the gap to disappear.
Because it's an odd being divided by an even, so it'll never happen?
No, it's not. It doesn't even have anything to do with the even and odd numbers. It's just because I've added or subtracted something to both numbers. Think about it like this. You play sports? What do you play?
Football.
Play football. Okay. How many games do you play in a season?
Okay.
Let's just say there's no playoffs.
Okay.
How many do you play? It's 9? Okay. You lose your first game. oh crap, you have a 100% loss rate. Now you win the next one. Now it's a 50% loss rate. The next one, 33%. The next one, 25%. And that loss rate will keep going down and down and down. But will it ever get to 0? No. You could win 1,000,000 games in a row after that, but you will never reach 0% loss again. And that's what's happening here. It's because I'm adding or subtracting things on the top or the bottom. It doesn't matter that the numbers are even or odd. It's that I have legitimately, even doing this, that small number will always just be a hair smaller than half the top. And that's what's happening. Yeah, KD ratio, back when I played PlanetSide 2. You know?
Oh my god.
All hail Vanu. All right. B. State the domain and range. Guess what? The vertical and horizontal asymptotes are telling you the domain and range. You have been told you will get to touch every single x except for x equals 1. So your domain is -infinity all the way up to x equals 1. But you can't include 1, so you hop over it with a union symbol. You pick it back up at 1 just on the other side of it, and you head to the right forever. So that includes every single number from -infinity to +infinity, except for 1, because I hopped over it with a union. And the range will do the exact same thing. You can hit every single y value, except for y equals 2. So the range would be from -infinity up to 2. Can't reach it, but you can hop over it with a union to infinity. There. It'll hit every single number. ID. C says find the axes intercepts. That means it wants to know where it crosses the x-axis and where it crosses the y-axis. C. All right, let's find the y-intercept first. That one's easy. Because for the y-intercept, x has to be 0. You're on the y-axis, so x equals 0. So y equals, I'll show the work, 2 times 0 plus 1 over 2, 0 minus 1. Well, that's just 1 over -1. There you go. This graph crosses the y-axis at y equals -1. The x-intercepts, because there could be more than one. Can there be more than one? Not in IB. In IB, there should never be more than one x-intercept. And that's because it'll always be linear over linear. I would have to introduce exponents on the top or bottom to have more than one x-intercept. So for your x-intercept, this implies that y equals 0, right? But y equals a fraction, right? Y equals 2x plus 1 over x minus 1. How is it possible that a fraction equals 0? Because that only happens one way. What do you got for me? If the top is 0. So the only way a fraction equals 0 is if the top is 0. It's the only way that happens. So the x minus 1 doesn't matter. So what we get is 2x plus 1 equals 0, and we solve for x. Subtract 1 from both sides, and divide by 2. Cool. We figured out where we cross the x-axis and where we cross the y-axis. We have a vertical asymptote, a horizontal asymptote, and what is the A, B, C, D? Part D. Question for me, sir. Yes, and that's what I was saying. The only way I can have more than one x-intercept is if I introduce exponents. But when IB does rational functions at IBSL, we only do linear over linear. Yeah.
So on the test, if you ask us to find the axes and intercepts, can we just show the equation and circle the answer we got? That's how you want it. Like we just circle -1.
Y equals.
Oh, so you write y equals -1.
Yeah. Because you have to tell me which intercept it is. Is that an x-intercept or a y-intercept? Okay. Part D, I think part D is asking us to describe the behaviors. We get close to the discuss behavior as approaches its asymptotes, and this is where we get a little weird, okay? Part D. I'm going to skip it for now. I want to do part D last. because it'll be easier for you to understand what's happening if you have a picture first. Now, normally, we wouldn't do that. Normally, excuse me, sorry, I just hit this puberty. Normally, we would use part D to do part E, okay? So let's get E over here, and E says sketch a graph. Picture not drawn to scale. Because who cares? I heard somebody say it. What is my vertical asymptote? Positive 1. So here's x equals 1. Yeah, we're not going to touch that number. And my horizontal asymptote, which we could cross, but we won't in IB because linear over linear, is y equals, it's a 2? I'm trying to do this from memory. Was it y equals 2? Okay. 1, 2. So y equals 2 ends up being our horizontal asymptote. And now we know where our graph, did I screw up? No, y equals 2 was the horizontal asymptote. Y equals -1 is the axis intercept. I cross the y-axis at -1. And I cross the x-axis at -1/2. So that's like here-ish. Yeah, it was at the horizontal asymptote was at y equals 2. And now I can connect the dots. Rational functions always have this kind of shape when they're linear over linear. Getting close to both of the asymptotes right there. And the really good news for you guys being an IB class is that because it is linear over linear, this rule will never fail you. Rational functions will always exist in regions that are diagonal from each other. So if you were to think of the red dotted lines as splitting this thing into 4 regions, the other part of this graph has to exist in the top right. The blue part exists in the bottom left, which means it must also exist in the top right. Just like that. It doesn't have a choice. If you were a little sketch on that and you were afraid, you're welcome to plug in x equals 2. You will get a number bigger than y equals 2, guaranteeing that the curve exists up there as well. Yes, ma'am? You mean will there always be 2 blue curves or 2 asymptotes? So the 2 blue curves in this course will always have to exist unless I restrict the domain. So I could say something like, oh, but x can only be bigger than 1. And then it would only be the one on the right side. Okay, but yeah, if I don't restrict it in any way, there will always be 2 because linear over linear always produces something like that. Yes, Aaron? How do you know the graph on the left goes down and the graph on the top goes up? How do I know? Yeah. Well, this one we know because we had the 2 axes intercepts. And vertical asymptotes, by definition, are a place where the graph shoots towards infinity. So because this was going down, I know this graph has to go down towards infinity forever because there is an asymptote here. And I know, because it's linear over linear, that the shape, they would have been like this, one of the 2. They would either would have been bottom left, top right, or top left, bottom right. The fact that I had blue curve in the bottom left forced blue curve in the top right. And the asymptote is again going to be hugged towards infinity. That's how that works. Yeah? If you ever have both of the asymptotes on the intercept, or on the axis? Can I have both asymptotes on? So y equals 0 and x equals 0? Yes. So y equals 0 and x equals 0 is this. It's the reciprocal function. It's actually the parent function. The parent reciprocal function, you can't have x equals 0, and 1 divided by a number will never equal 0 either, so 0 and 0 both end up being intercepts. Yes, Erica? Do you mean side by side instead of diagonal? Yes. Okay, so Erica asked, is it possible to look at the equation and know if the curves will be side by side instead of diagonal? It'll never happen in this class because IB only does linear over linear. And when it's linear over linear, they are forced to be diagonal from each other. But the only time that they're side by side is when you introduce either absolute value signs, because then no negatives are allowed, or squares, because again, no negatives are allowed. So if you said, what is 1 over x squared, which we don't do in this class, 1 over x squared looks like this. because it doesn't matter what x you plug in, it's going to return the same positive y value. But that doesn't happen in IBSL, so we don't have to worry about it. See, Erica, you're concerned because you remember how scary things were in pre-calc. The pre-calc material in this course and trig material in this course are easier. The way they're assessed, though, drastically different. The material, easier. Now let's do part D, and part D is the weird one. And I think it'll be a little bit easier for you to accept what I'm about to do because you have a picture to look at. The book wanted us to do part D first, clearly. The authors wanted us to, but I'm telling you, when it's the first time you've seen it, looking at this picture first is better. You have two different asymptotes, and you can actually approach these asymptotes from two different directions. So let's do this. As x goes towards negative infinity, y goes towards, okay, now you can look at the graph, and you can see, as x heads towards negative infinity, what y value am I approaching? 2, the horizontal asymptote. By definition, that's what a horizontal asymptote is. It is you approaching this value at infinities. But more powerful than saying I'm approaching 2. Am I approaching 2 from above 2 or from below 2? I'm below it. That is math speak for, yeah, you're getting close to 2, but you'll always be just under it. That's what that means. It's 2 minus, meaning 2 minus something tiny. You'll never actually get there, but you will be below it. And you could say, as you who said they haven't heard of it, Krill, you did, in limits. This is IB's version of a limit. Okay? As x approaches positive infinity, meaning as you head towards the right, really, really far right, again, definition of an asymptote is something that you're getting close to at the infinities. So I'm clearly approaching 2 again. Y is approaching 2. However, I will always be just above 2. And you have the ability to tell me that without graphing. They wanted you to do this before graphing because it would have told you where the curves go. So, Michael, because you and I ever talked about it, let's prove to everybody and ourselves that we knew this before we graphed. Cool? We plugged in the number 10 quadrillion, right? The top of this fraction ended up being 20 quadrillion and 1. The bottom was 10 quadrillion minus 1. I don't know what that number is. Now, is the top bigger than double the bottom or smaller than double the bottom? This one was 20 quadrillion and 1. This one was 10 quadrillion minus 1. So the top, which we already knew the top was a bigger number, but more specifically, it was just a hair bigger than double the bottom. So we knew that we existed above the 2 there. Now, when we go the other way, when we plug in negative 10 quadrillion, we have negative 20 quadrillion, but then plus 1. So now you're closer to 0 than you were before by 1 unit. But on the bottom, it's negative 10 quadrillion minus 1. So because I got closer to 0 when I added 1, I'm actually a little bit less than double the bottom now. And that's how we would have known where to put the curve. The shortcut is, in this class, linear over linear, they will always be diagonal from each other. And if you know one of the axes intercepts, you know where half the curve exists, which means you know where the other half exists. Okay, that's the shortcut. But that's not all. Not only can we get close to our horizontal asymptote, we can get close to our vertical asymptote. Oh, that's red. I don't want it. I don't like it. Take it back. As x gets close to the number 2, what is y doing? Oh, not 2. I'm sorry. As x gets close to 1, my vertical asymptote. As x gets close to 1, what is y doing? You hear my speaker? What is happening? Okay, it stopped. So as x gets close to 1, what's my y value doing? Negative infinity. But isn't it going to positive infinity over here?
No.
You just discovered a problem for us. And what's the problem? They're going opposite ways. So I didn't give you enough information when I said as x goes to 1, did I?
Yeah, I could put a little minus.
I had to put a little minus or a little plus because I need to tell you on which side of 2 you are, or 1. So as x approaches 1 from the left of 1, just smaller than 1, this one goes down to negative infinity, like you said. But as x goes to 1 from the right side of 1, meaning a number just a hair bigger than 1, now my y's are shooting up towards infinity, and once again, you could have done this without graphing. And I'll prove it to you. You follow old Rafiki. He knows the way. So I'm going to plug in a number just a hair bigger than 1. Let me plug in the number 1.000000001. I'm going to double that number now because I just plugged it into the top. I now have 2.00002. Now I'm going to add 1 to it. Now I'm at 3.002. Okay, now let me plug that same number on the bottom. 1.001, and then I subtract 1. What I'm left with is 0.001. I have a constant positive number on the top and a ridiculously tiny positive number on the bottom. And I don't know guys if you've ever realized this, but what happens to constants when you divide by tiny, tiny numbers? They get really big. And that's the proof that if you were a hair to the right of 2, or a hair to the right of x equals 1, you were shooting up to positive infinity. And in fact, the closer you got to 1 from the right side, the bigger that y value would have gotten, because the decimal on the bottom would have been even smaller. So you could do this without graphing, and IB would like it if you could do it without graphing. IB would like it if those thoughts is what gave you your graph. Again, the shortcut is just find the x-intercept or the y-intercept. When it's linear over linear, they will always be diagonal from each other. So if you know where one of them is, you know where the other one is. Then you have the ability to talk about what's happening around the asymptotes, because how would they know what order I did it in, right? Okay. Yikes, right? Little did you know. We don't do that. We don't do as y approaches things too much. Even in calculus, it's always about what's happening as x gets close to, because you care more about what's going on domains than you care about what's going on ranges. Consider this function, 6 over x minus 2 plus 4. It says determine the equations of the asymptotes. Okay, well, A. Let's do the vertical asymptote. That one's easy. X equals what? X equals positive 2. Vertical asymptote, x equals 2. Because you can't plug in x equals 2. You're not allowed to divide by 0. You plug in positive 2, and you get 6 over 0. Wrong. No, can't do that. Okay? But the horizontal asymptote. I said it's usually leading coefficient of the top divided by the leading coefficient of the bottom. I don't see any x's on the top. And since there are no x's on the top, what is the leading coefficient there? It's 0. You could think of this as saying 0x plus 6 over 1x minus 2 plus 4. You could pretend it says that. So whoops, I forgot my equal sign. So if you wanted to do leading coefficient over leading coefficient, you would get 0, correct? But then there's a plus 4 afterwards. And 0 plus 4 is 4. This is a transformation, guys. Well, I added the 4 because it's simply a plus 4 out there. Here's the thing. On the last example, there were no numbers outside of the fraction, was there? I could make sure that 4 has the same denominator, has an x minus 2, and then I would have had to distribute it. It would have been a 4x minus 8, and 4x minus 8 plus 6, 4x minus 2. or 4x plus 2 is what it would have been on top had I combined them. So it would have been 4x plus 2 over x minus 2, and now you get 4 over 1, so you still get the 4. But instead of doing all that work, I want you thinking about transformations. The parent reciprocal function, who was it that asked me, could it be both axes, could they both be 0? The parent function, y equals 1 over x, has a vertical asymptote and a horizontal asymptote of 0. It does this. And then if you shift it up by any number, the horizontal asymptote shifts up by that much. So the moment you see something like this, where it's not linear over linear, it's constant over linear, plus a number, that number will be the horizontal asymptote. And you don't have to worry about trying to memorize that. You just set it up like this. If you set it up like that, you go, oh, look, it's 0 over 1 plus 4. 4. It didn't have a choice. Okay? If it had said 6x over x minus 2, then the horizontal asymptote would have been 10, because it would have been 6 over 1 plus 4. Okay? So the quote-unquote trick is still working. B, domain and range. Well, we've already seen how to do this. The domain will be every number except for x equals 2. And the range will be every number except for 4. There. Find the axes intercepts. Well, the easy one, just like before, is finding the y-intercept. That's always easy, because when you're on the y-axis, x equals 0, right? So ABC. Let's do the y-intercept, which implies that x equals 0. So we plug in x equals 0, and what we get is y equals 6 over 0 minus 2 plus 4. That's negative 3 plus 4, positive 1. We cross through the y-axis at positive 1. Comfortable with that? That's not too scary. Now, the last time what we did was we said, wow, well, for the x-intercept, y equals 0, which means the fraction equals 0, which means the top equals 0. So here that's going to happen when the top is 6. Can it ever be 0? No. So what does that tell you? No x-intercept. That's exactly what it tells you. This thing does not cross the x-axis. Are we sure? Ah, there we go. You see, here's the thing. When you have x's on the top, you can set the top equal to 0. And if the plus 4 hadn't been there, then we would say it doesn't cross the x-axis. But that plus 4 it doesn't cross 4. So it's causing us an issue. So what do we have to do? Well, I said we're going to have to do a little bit more work. I can't really do the shortcut. For this one, you need that y equals 0. So for this one, you actually have to set 0 equals the fraction. Was it minus 2? Yes. Plus 4. And you actually have to solve for x. And if that 4 hadn't been there, we wouldn't have to. That 4 is what's making us solve for x. If the plus 4 wasn't there and it was just 6 over x minus 2, that fraction can't ever equal 0. You wouldn't cross the x-axis, but the plus 4 is goofing us up. So what do? We subtract 4 from both sides. Uh-oh. Now what? Yeah, we get rid of fractions. We get rid of fractions by multiplying everything by what's on the bottom. Distribute that x minus 2 to the left and to the right, and you will get negative 4 times x minus 2 equals 6. And you do have to distribute the negative 4 and go through all of this algebra 1 stuff. I'm just going to do it over here so I don't have to keep going down. So let's bring myself over here. Negative 4x plus 8 equals 6. Subtract 8 from both sides. Subtract 8 from both sides. And then divide both sides by negative 4. And you get x equals negative 2 over negative 4, which is 1/2. So we do cross the x-axis. We cross it 1/2. We cross the y-axis at 1. I can't remember what the question tells me to do, so I scroll up. It says, discuss the behavior as it approaches the asymptotes. Yeah, I'd rather graph it first, and then we'll discuss about that. Because it's easier, and they don't know what order we did it in. So A, B, C, D, so we'll do E over here. Afterwards, we'll cheese it and come back and do D. Cool beans? This is what I want you to do in your homework, too. I want you to cheese it. Catch up with me, panel. Thank you. Don't draw the graph. No, they don't do that. They're not trying to trick you. So what do we have? We had a vertical asymptote at x equals 2, correct? X equals 2 is a no-no. You do need to mark your graphs, though, for IB. If you don't put numbers on the scale, you don't get credit. They're not going to assume that 2 tick marks is 2. And the horizontal asymptote was 4. See what I just did right there? That's enough. 4th tick mark was a 4, so they get it. I'm going by 1s. That's enough. You know, it clues you in. Cool beans. What do we know? We know the y-intercept was positive 1. And we know the x-intercept was positive 1/2. And if it exists in the bottom left, it exists in the top right. It doesn't say graph, it says sketch. That's a sketch. It's good enough. Sketch is basically saying, get good enough. G-I-T-G-U-D, get good.
It's a line. What do you want from me?
Yeah. Now we can discuss our asymptote behavior because now it's easier. As x heads to the extreme far left, my y values, they're going to get close to 4. Oh yeah, but they'll always be just under it. As x heads to the extreme far right, my y values are going to get close to 4, but they're always going to be just above it. Because the picture told me so. It's easier this way. As x heads towards the number 2 from the left side of it, meaning just smaller than 2, my y values are crashing down to negative infinity. And as x gets dangerously close to 2, but just a hair bigger, my y values explode up to positive infinity because the picture said so. I think it's much easier to graph it and eating that delicious Gouda and cheesing it to get the asymptote behavior. Much, much better.